Hi and good evening Dr. Ho. So we are from Group 2 has decided to present about processing of corn oil.
For introduction, processing of corn oil. Corn oil, one of the commonly used vegetable oils in our daily life. Corn, although known as a cereal, actually contains a small amount of oil, mainly found in the germ part of the kernel. Corn oil is widely produced through industrial processes such as wet milling and dry milling, where the germ is separated and processed to obtain the oil. For introduction,
Flow processing of the corn oil. Step 1. Harvesting and delivery. Corn is harvested using industrial machines and transported to processing plants by trailers. At the facility, the kernels are unloaded and washed using water-based system to remove the surface dirt. Step 2. Pre-cleaning and sorting. The corn undergoes the cleaning using vibrating screen, air separators, and gravity equipment to remove impurities such as dust, husk, stones, and metal fragments. Step 3. Steeping and wet milling. The clean kernels are soaked into steeping tanks under controlled temperature and pH to soften them. The corn is then milled into slurry, allowing separation into starch, fiber, protein, and oil-rich germ. Step 4. Germ separation. The germ is separated from other components using gravity separation, where the lighter germs is floats and is collected as the main source of oil. Step
Next step, which is mechanical oil pressing. The separated germ is dried and fed into the screw presses, where pressure is applied to extract the crude corn oil, leaving behind a solid residue known as a press cake. Next step, which is solvent extraction. The press cake goes through the micellar process, where hexane is used to extract the remaining oil. The oil mixed with the solvent to form a micellar, which is then heated to separate the oil. The solvent is recovered and reused in the process. After that, we will go to the next step, which is oil refining. The crude oil is refined through the several steps to improve its quality. It involves deguming to remove the impurities, neutralization to reduce acidity, bleaching to remove color, and deodorization to eliminate the unwanted smell, which last but not least, bottling and distribution. Finally, the oil is filtered and filled into the bottle using machine. The bottles are sealed, labeled, and packed before being distributed to consumer. Last but not least,
the first step is harvesting and delivery. One major issue is moisture variability and kernel damage. Corn often arrive with high moisture and broken kernels. The other critical problem is mycotoxin contamination, such as aflatoxins. These usually come from poor field or storage conditions. Finally, logistic delays are a concern. If processing is delayed, enzymes start breaking down the oil and heat can build up in storage. The second step is pre-cleaning and sorting. Sometimes, contaminants like stones or metal are not fully removed due to equipment issues. Dust explosion hazard. Fine corn dust is highly flammable and poor ventilation can lead to dangerous explosion. Lastly, this system requires high energy and maintenance. Now, let's move into steeping and wet milling. Steeping uses warm water, which makes it easy for microbial growth if conditions are not controlled. This can cause. Finally, during milling, emulsion can form between oil, protein, and starch. Germ separation. One key issue is inefficient germ recovery. If conditions are not optimal, some oil remains trapped, reducing yield. Also, overmilling can damage the germ, making it harder to separate. Germ separation. Next, the germ fraction may also contain impurities like fiber and protein, which finally, there is a risk of oxidation.
Step 5. Mechanical oil pressing. The corn germ is pressed to extract crude oil. However, problems such as non-optimal pressure and overheating may occur, which can reduce extraction efficiency and damage oil quality. Next, in step 6, solvent extraction. The remaining oil is extracted using food-grade solvent. The main issue here includes solvent residue, which can affect food safety as well as the fire hazard due to the flammable nature of the solvent. Oil refining. The crude oil is purified through several stages, issues such as incomplete deguming, excessive chemical use, and nutrient loss during deodorization. Step 8. Bottling and distribution. The oil is packaged and delivered. Common problems include contamination, leakage, oxidation, and labeling error.
For step 1, harvesting and delivery. To solve this problem, moisture meter and cooling dryer are used to stabilize water content while gently handling reduced cracked kernel. Next, for mycotoxin contamination, natural preservative like essential oil or preservative can inhibit fungal growth during storage and transport, and it reduces mycotoxin. Next, step 2. In this step, energy and maintenance burdens are the main issue. So to reduce it, installing energy efficient motors, predictive maintenance program, and modular equipment design step. Next, step 3. Steeping and wet milling. In this step, microbial growth is the main issue. So to prevent it, maintaining proper SO2 level, pH, and sanitation system. And last but not least, emulsion formation is minimized by adjusting milling condition and using demulsifiers. In step 4, there have 4 issues that have been mentioned. So the first issue is inefficient germ recovery. So to solve this problem, by optimizing slurry viscosity and particle size, germ damage is reduced by controlling milling speed. Step 5, mechanical oil pressing. Non-optimal pressure is solved by calibrating screw presses and applying variable pressure control. And for overheating issue, Stewart and Arnold has been discussed this issue by installing jacket around equipment. Step 6, solvent extraction. The issue in this process is solvent residue. Mosley has stated that this issue can be solved by using vacuum distillation. Next, fire hazard are controlled with explosion-proof equipment and ventilation. In Step 7, oil refining. Incomplete degumming is solved with enzymatic degumming for better phospholipid removal. And for the excessive neutralization issue, alkali dosing is used for preventing this issue. And in effective blanching is improved by optimizing adsorbent dosage and contact time. Next, for the last step of corn oil processing, which are bottling and distribution. So for the first issue is contamination during bottling, and it's solved with sterile filling lines and HEPA HEPA filtered air. Oxidation during storage is minimized with nitrogen flushing and dark PET bottles.
For conclusion, corn oil, a byproduct of corn processing, is a valuable, nutritious and stable vegetable oil with wide application in both food and industrial sector.